Hello, I welcome you all to this another interesting screencast. The problem reads: the car is traveling along the road with a speed of v equal to 2s. That is in units of meters per second, where s is in meters. Determine the magnitude of its acceleration when s is equal to 10 meters. This problem is coming from the mechanics of materials, engineering mechanics. Engineering mechanics dynamics at 14th edition by R.C. Hibbeler. So we have a car that is traveling with a speed of the speed of v equal to 2s, and s is in meters. We are being asked to determine the acceleration when s is equal to 10 meters. Right. So we have our velocity, okay, which is being expressed as s dot, and this is equal to ds dt, and we've been given is 2s, okay, where s is in meters. And then our acceleration, okay, so if we are to express this velocity as a vector, then we'll have this scalar quantity then times the unit vector along the t axis. So we are going to be using the t and the n axis. The t is tangential to the curve and n is normal. Okay, at right angle. These two are at right angle to each other. So acceleration itself, acceleration as a vector is going to be equal to component in the t direction times the unit vector and the component in the n direction and the unit vector. And this AT is going to be equal to v dot, okay, and v dot is just dv dt, right? But then our v there is expressed in terms of 2s, so we need to use chain rule. So this is going to be equal to dv ds, okay, by ds dt, okay. And our ds dt, we already know it, okay, so we just replace there, right? And our dvds, we already know it also. Our dvds, this is just going to be equal to dv, then there we have a 2s, okay, then this is just going to be equal to 2. So replacing this here, okay, this becomes our 80 is equal to 2 by 2s, right? So this becomes a 4s. And then at s equal to 10 meters, therefore we'll have a at 10 meters is just going to be equal to a 4 by 10, which is just equal to 40 meters per second squared, right? And then we have an, okay, which is just equal to v squared divided by rho, where rho is just equal to the radius of the curvature. In our case, it is 50 meters, right? And our an will just be equal to our v squared. Our v is 2s, okay, squared divided by 50, okay, which is just going to be just equal to 4 over 50 s squared. And then an at s equal to 10, this is just going to be equal to 4 divided by 50 times 10 squared. And this just gives us 4 divided by 50 times 10 squared. So this gives us 8 meters per second squared. So we've calculated the two values. Then we'll need to use Pythagoras theorem to find out the magnitude. So a will just be equal to square root, okay, the square root of at squared plus an squared. Alright, and our at we said is equal to 40 meters per second squared, and our an is just equal to 8 meters per second squared. Therefore, our a will be equal to our a is equal to, that's 40 squared plus 8 squared, square root of that. So this we get a 40.79 meters per second squared. Let's show this. So let's consider this is the point at s equal to 10. Okay, let me draw it properly. Let's say something like so. And let's say we have another component like so. Okay, and then we have component like so. Alright, so let's call this one here A, we call this one AT, and this one AN. And then let's outline the final solution, which is this one here. Right, I think we are done, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast. Of course, this one we are saying at this point is equal to 10 meters. Alright.